Last lecture, same the normal forms CNF and GNF, but GNF grammar into CNF or GNF. Examples of conversion. Today we'll see some examples, some different type of examples for generating grammar, and then we will see the conversion rules for AFA and conversion of grammar to DFA, DFA to grammar, and regular expression to grammar. First, try to solve this. Find is equal to one or more times repetition of A, then is equal to B, B, AB, AB, so on. One more times repetition of A followed by single B. Then language L over alphabet AB, where equal number of A and B are there. A power n, B power.
What?
Any doubt? Same can be A power n, B power n, where n is greater than 0. In first case, n is greater than equal to 0. Second case, it is n greater than 0. Then L equal to W, set of strings W, where W is a string generated from AB. Any number of times A and B can be used, and W is A1 palindrome, A1 length palindrome. Next, W for alphabet AB. Alphabet we can consider anything AB 0, 1. The question variation will be with input alphabet. W is mod length palindrome. Try to find grammar for these questions. Next, seventh question. Language is 0, 0 plus 1 bracket star 0, 1, 0 plus 1 bracket star. Regular expression is given. For that you have to find grammar. Then a power I, b power j. That is a repeated I times and b is b is repeated j times, where I is less than equal to j less than equal to 2i. And I can be greater than equal. L is equal to a repeated I times b repeated j times c repeated k times, where I plus k is equal to j and I comma k greater than equal to 1. So here number of b is equal to number of a plus number of c. L is equal to a repeated I times b repeated j times c repeated k times, but I is equal to j plus k. Again j comma k greater than equal to 1. You can change this question anyway by any combination. I is equal to j plus k, I plus j is equal to k, I plus k is equal to j. Then I is equal to j is equal to k. This way you can repeat it. Okay, try to find answer for these questions. First one is simple. For each, there is only one input A. Each string will have number of occurrences of A. So A is repeated multiple times. But I can write yes produce A or it may produce AS. So this yes can be replaced further with any of this production. So minimum one A is generated. Second, what it generates? One B, right? At the end, it generates one B. And before that B, that means number of A's are there. Number of A's are there. So for if we consider this part, no, number of times A is there. So we can use first question or first one. But minimum number of times A repeated is 0. So it is epsilon. So what I can say, either it may generate A yes or it can generate B. Now this yes can be replaced with B. At the start it can generate only B if we consider 0 times appearance of A. If A is repeated 0 times, then it is only B, or it can be A then followed by yes. Again this yes can be replaced with any number of A's, AS. So AS, ASS and continue. At the end yes will be replaced with B. So string ends with B. Anyhow it will end with B. Then here what we want? Equal number of A and B. So whenever A is produced, it should produce B. Whenever A is produced, it should produce B. Now at the start A is there, at the end B is there. For this A, B is there. In between, again what we have to generate? For each A, there is a B. Again middle part, for each A, there is a B, and for each A, there is a B. So this part is there. For each A, we are generating B. At the center of that, again we can have AB. What it can be? A yes, B, B, and keep on this replacing. Okay. Another thing, it can be epsilon. It can be epsilon. So yes can be replaced with epsilon. Yes can be replaced with epsilon. So this will be the production rules for third question. A small change will be there for the fourth because it does not have epsilon. Epsilon is not part of the fourth question. So instead of epsilon, what it will generate? AB. This will produce AB. And second transition, it will be second production is ASB. So this way production rule will be there. Then even length palindrome. Even length palindrome. Even length and odd length. Again it will be somewhat similar. A small change will be there. Now what S has to produce? If at the start it is producing A, at the end it should produce A. If at the start it is producing B, at the end it should produce B. So depending on the first alphabet, last alphabet is there. Now after A it can be B, or after B it can be A, or anything can be there. So A is produced by S, B is produced by S. Replace middle part ASA, BS, B. Now we have the condition even or odd. For even, either middle will be AA or it will be BB. So it can be of length 2, or what you can have epsilon. Instead of AA, BB, you can have epsilon. So here it will be AA and here it will be BB. Or 0 string with 0 appearance, again it is also odd even length palindrome. It is also even length palindrome. So we can have epsilon. What about odd length? We cannot have epsilon. There we have A or B. Middle character can be A or B. This is for even length. These two plus this one is for even length. Then seventh regular expression is given. Now what it can be? Yes, produce. Some part is repeated. This part is repeated, right? 0 plus 1 bracket star. Other parts are not repeated. Other alphabets are not repeated. So it is 0. Let me write yes 1. Then 0 1. Again yes 1 and 1. Now what is yes 1? It is repetition of 0 or 1, and that is 0 or more times. Repetition of 0 or 1, and that too 0 or more times. So what we are going to do, yes1 should produce 0 yes1, or it can produce 1 yes1, or it can be epsilon 0 times. So we can have 0 0 1 1. This string is possible because alphabets are repeated 0 times, so epsilon is there. So 0 times repetition, that's why epsilon is there. So these are the production rules for 7th. 8th one, number of A is less than equal to number of B. The number of B, it can be less than equal to twice number of A. That means if I have, what are the possibilities? If I have 3A, it can have 3 B's. It can have 3A and 4B. So number of B, it should be less than twice of number of A. Here 3 is there and it is 4. So 3 times A and 4 times B. 3 into 2, it is 6. So number of times B can be repeated. It is maximum 6 and minimum 3. Minimum 3 because I is greater than or equal to J. It is not less than. I is greater than equal to J. So it can be equal to or greater than. So it can be 3, 4, 5 or 6. Up to twice. 3 into 2, 6. So it can be 3, it can be 4, it can be 5, it can be 6. Anything. So for each A, either I have to produce 1B, or for each A, it should produce 2B. So maximum number of B's for each A, it will be 2, and minimum number of times B for each A, it will be 1. Now we have to repeat this part. So we are repeating it, and it will be produced from yes. It will be produced from yes, and yes produce. Now what can be the production rule? What is the given condition? What is the given condition? I is greater than equal to 1 or I is greater than equal to 0. Yes, anyone?
Greater than 1.
It is greater than equal to 1. So we cannot have epsilon over here. I cannot write epsilon, else it will become 0. If I write epsilon, it becomes length of string to be minimum length to be 0. So it is not allowed. What I have to write? It should produce AB or A double B. Now we can check. You can generate any string. What it will have? It can have minimum number of A and number of B to be equal, or number of A equal to number of B equal to twice number of A, that is maximum, and in between that you can have strings. So number of A, if it is 2, then it will be number of B equal to 2, 3, 4. If number of A are 5, then it will be 5, 6, 7, 8, 9, 10. From 5 to 10, including, it is inclusive of 5 and 10, any range, any number of times B can repeat. Then ninth one, A I B J C K. A is repeated I times, B repeated J times, C repeated K time. I plus K equal to J. That is, for each A there is a B, and for each B there is a C. For each A there is a B, for each B there is a C. Number of A followed by number of B. It is not that A is B followed by B and again B is followed by A and then C. No, A is followed by B and B is followed by C. I plus K, that means number of A plus number of C equal to number of B. I K greater than equal to 1, that means at least one A and one C will be there. So minimum string, it will be A, B, B, C. Divide it in two parts. This one. Write production this part. For each A there is a B. Each B there is a C. What it can be, right? A, B. I can have one B and one C. They are not equal. This is the condition. Number of A plus number of B. It is 4 equal to number of B's. Number of A plus number of C. B plus 1 equal to number of B is 4. Match the condition. That means can not have condition where number of A equal to number of B and number of C. We are not having that condition. So we, if that condition is there, then we cannot have the uh, division like this. We'll have another production rules. For this, consider left part AB and consider right part BC. What will be the grammar? For each A, there is a B. I can repeat this part any number of times. So it is A, yes, B. This is first part of the string AB. It is followed by second part. Now what is second part? BC. I don't know how many times B and C will be there. So it will be, guess what? Or it is A, B, yes, with this part. Okay. Yes, one. First we'll write yes, one. What it will be? It will be or if you are getting confused with this, just do this. Say this is one string and this is, write it as X and it is Y. The X consists of AB. X consists of A and B. I don't know what B will consist of, but it is combination of B and C, number of B followed by number of C. We will generate them individually. It will be easy. X and Y. These are capital. Now, X productions. For each A, there is a B. and we can repeat this part, or it can be AB, can be AB. Then what will be Y production? B, Y, C, or B, C. Individually they will produce their production rules, so it will be easy to understand. X dot Y, first part is X, second part is Y. Produce X independent of Y, and there will be concatenation. So this is a regular expression, X dot Y. X producing some regular, X producing some grammar CFG, concatenated with Y is producing some CFG, producing some strings, and those strings will be of CFL. And when you concatenate them, you will get CFG or context-free language. This is the production. These are the production rules. 3 production rules for question number 9. Is 9. Will be 10th. I is equal to J plus K. For each A, there is one B and one C. Double A followed by B, C. One A for B, one B for C. What will be the production? What you have to match that I have shown here. Middle AB and start with end. This is the part that you have to separate out. Then this will be mapped. What will be the production? Anyone? Just let's say it is X. Let's say this is X. So in between it is X. It can be any number of A and B. Let me write A, B, B, C. What it can be A, B, C, C. So middle is AB. Last A matched with this B. First two A matched with last two C. So any combination is possible, but A followed by B, B followed by C. So middle part, we will separate out it as X. So let me write X. Let's say middle part is X. Before X, what I can have? A, and after X, it should be C. If A is there, then it should be C. So what it can be? A, X, C, C. In A, X, C, C, C. Number of A equal to number of C. And for X, what it has to produce? Number of A equal to number of B. X producing A, okay. What is the problem in this case? I write X. Can you repeat A and C? Repeat A and C. To repeat A and C, I have to write here. Should be A, yes. What I can do, I can replace this S with ASC, ASC, ASC. At the end, I will replace it with AXC. So we will come out the recursion of S. Will come out of this recursion of S. Now it goes to x. From x we are not going back to s. It should be axb or ab. It should be axb or ab. Now these production rules will produce the required string. So these are the production rules for 10th. You can change this part, this condition, and you will get variations. J is equal to I plus k, I is equal to j plus k is equal to I plus j, anything, whatever you want to write. Try one question to find for this one. Same condition, AI, BJ, same inputs will be there, but I is equal to j or j is equal to k. Either condition should match. It should not match both the conditions. Either A is equal to B or number of B equal to number of C. These are some important questions that were left out. Try out more questions, find out on the internet. We'll get some more questions. Okay, next point. Chomsky hierarchy. So there are 4 types of grammar or 4 types of languages. Type 3 grammar is the regular grammar. Type 2, the grammar which we have understood in this unit, CFG, context-free grammar. Then type 1, this is the grammar which is context-sensitive grammar. For this we have linear bounded automata. For linear grammar we used regular grammar we use finite automata. In the first unit we have seen what is regular language, then what is finite automata. So that is what type 3 regular grammar, and we are using FSM for regular grammar or regular language. Example is A star, B star. Any number of A followed by any number of B. Second, type 2, it is context free, which we understood in the second unit. The language is context free language and grammar is called as a context free grammar. And to accept this language or to determine this type of language, we are using PDA. So we will see one example of PDA today itself. Language is A power n, B power n. Now for this we cannot have finite automata. We need grammar only. And to accept this type of or to determine whether this language string belongs to this language or not, we are using PD. So whether given string satisfy the conditions of given grammar, that we need to determine using PD. So to understand whether the statement of a program, whether it satisfy the condition, at the end is there a semicolon, If there is a conditional loop or conditional statement, if, then whether if is followed by opening bracket and closing bracket, then internal part of that opening and closing bracket, whether it is a logical statement, is there any true false condition? If it is there, then only it will be correct statement, else it will generate a error. So that is the part where it is used. Then type 1, they are context sensitive. The grammar is context sensitive grammar. For that we are having linear bounded automata, and for that somewhat we are using grammar CFG only. This type of statement or languages, a power n, b power n, c power n. Number of a equal to number of b equal to number of c. This is difficult to match. This one is difficult to match. So how to map that one, that we will see. We will see this example also. And for this, the language is called as a decidable language. Language is decidable language. The last is type 0. It's called as computable language. Computable language. It is unrestricted grammar. There is no condition on grammar. And for this we have Turing machine. The example is n factorial. That is the example. Now, what is Turing machine? What is PDA? That we will see. And what are the languages which are not accepted by or determined, recognized by finite automata, CFG, or PDA or LBA, linear bounded automata. All those languages, including these three languages, including these three, other languages are there which are not recognized or accepted by these three. Those are part of this unrestricted grammar or computable language that can be accepted by Turing machine. That we'll see in the 5th unit. Here are the classification, 4 types of grammar, type 0 to type 3. Type 3 is having much more restrictions, and type 0 is no restriction, unrestricted grammar. Now, next point, the last lecture I told you, left linear and right linear. These are the types of grammar, regular grammar, left linear and right linear. So what it is? In right linear grammar, in each production rule, in case of right linear grammar, for each production rule, if we have a non-terminal, then that non-terminal will appear as a rightmost symbol. If it consists of non-terminal, if only terminals are there, then on the right hand side there is no question about the position of non-terminal. Whereas in left linear, it will appear as a leftmost symbol here, leftmost symbol in the production rule. A is producing capital B, small a. B can be followed by any number of terminals. This is left linear and right linear form of a grammar. Now, where we are going to use it, left linear and right linear. While converting DFA to CFG. That means regular language conversion to regular grammar, and that regular grammar represents the language is or the set of strings accepted by DFA. While converting DFA to CFG, we are using left linear or right linear grammar. While converting, there are some rules for conversion. What is the DFA? We have 5 tuples: Q, alphabet, delta, Q naught, and final state, set of final states. While converting it to right linear regular grammar, it is a regular. It will be a regular grammar, because for each context-free grammar, DFA does not exist, DFA or NFA. But for each DFA, NFA, a context-free grammar can be written. That is the condition. That is the restriction. So we can represent every DFA using production rules or set of production rules, that is using grammar. And while converting DFA to production rules format, that is the grammar format, what we have to do is rename each state with capital alphabet. Now here capital alphabet, why it is required? Because for non-terminal we are using capital alphabet. So it is A, B, C, D, like this. Second case, rename all the states of Q with these names. So rename each state, and while renaming there is an initial state. So this initial state should be renamed as a capital yes. So this should be first rule, because we are starting at initial state. So initial state rename as a yes. Second, rename each state as capital A, B, C, D, and so on. Third, set of production rules need to be written. Set of production rules need to be written. And while writing that, what we have to do is, if any state, if any state is generating or is having a transition, let's say Q naught is having some transition to QF, Q naught to QF on input A. Then if I rename it as yes, what should be written as yes produce A. Yes produce A. That is the production rule. And if it is non-final state, then what we write is, let's say it is Q naught on input A goes to Q1, then it will be A. Yes produce A, A. Q1 is renamed as capital A. The input on transition is written as it is. So it is there. If Q naught itself is a final state, if Q naught belongs to final state, then yes produce epsilon. If Q naught belongs to final state, then yes produce epsilon. This is production rule that we have to add. If it moves to final state, then on input A, it is moving to final state. So there is no non-terminal on the right hand side, only terminal is there. And if it is non-final state, then yes produce AA, or whatever the non-terminal is there, that we have to write. Similar is the case for other transitions. Let's say Q1 on input B, it moves to some state Q2. Then if I rename it A and B, transition will be B, B. If input A is also there, then it will be A, B. A producing BB or AB. If Q2 is non-final state, Q2 is non-final state. And if there is a transition, let's say Q1 to Q0, back to initial state on some input 1, then it will be A1 yes. A producing 1 yes. Yes is for initial state, 1 it is the input on transition, so it is as it is, and capital A is for Q1. So that way we have to write the production. Clear? Is it clear?
Yes, sir.
Okay, let's solve some questions. Or mm, okay. First, I will explain reverse part, vice versa. Right linear to DFA. The reverse is the case. It will be similar if production is of the form. What is it? Right linear to DFA. A, B. Then what it denotes? A on input small a moves to another state B. Just rename it Q1 on input A, Q2. Wherever B will be there, it should be renamed with same state. You should not have different names for same. If you have another transition, let's say B capital C, then C on input A, it is B, then what it will be C on input A, it goes to back B. So here it is Q3 and it should go to Q2 only. It should not have new state because B is already there. So whatever renaming is there, we should use same name for all the transitions and for all the production modes. See, it is renamed as a Q3. So for Q1 on input B, there is a transition to state C. That is what? Q3. So this way we have to convert it right linear to DFA and DFA to right linear grammar. That way we are going to convert grammar to finite automata and finite automata to grammar. So just find out this is even number of A and B, or let's see even number of 0 and 1. So if it is 0, 0, 1, 1. So even number of 0 for each 0, first 0, second 0 is there. For each one, there is a second one, or it may be followed by 0 and again 0 and then 1. Here it may be 1 and back 1. So find right linear grammar for this one. Right linear regular grammar. Right linear regular grammar. This is DFA to right linear. Find grammar, and for second, even grammar is there. Just produce B, B, capital B. It produce B, capital C, or it may produce B. Let's say have a self loop and I can have, let's say C, small c, capital C, A or B. Find DFA. According to rule, Q naught is a final state, initial as well as final state. Total with the transition. Rename all the states. So Q naught, it is yes. Q1 is A. Q2 is B. Q3 is capital C. If Q naught belongs to final state, that is set of final states, then add the transition yes produce epsilon. Condition is yes produce epsilon. Add this transition or production rule. So for that transition, this is the production rule. Now from yes, what are the outgoing transitions? From yes, that is Q naught, what are the outgoing transitions? Q naught to Q1 on input 0 and Q naught to Q3 on input 1. From yes on input 0, from yes on input 1. For input 0 on Q naught, next state is Q1. Q1 is renamed as capital A. For yes, if input is 1, that is Q naught. If input is 1, next state is Q3. Q3 is renamed as a capital C. Then Q1. Q1 is renamed as A. Right, A. From Q1 outgoing transition 1 to Q naught and second is to Q2. Q naught is reachable on input 0. So it is 0s. From A, transition on input 1 is to state Q2. Q2 is renamed as a B. Then from Q2, that is from B, on input 0. Next state is Q3. Q3 is renamed as capital C. From Q2, capital B, on input 1. Next state is Q1 and Q1 is renamed as a capital A. Then from capital C, that is Q3, outgoing transition on input 1. Next state is Q naught. It is renamed as yes. From Q3 on input 0. Next state is Q2 and Q2 is renamed as B. Okay. From Q3, we are moving to final state as well as initial state. So for initial state, we have added transition. What about final state? It should be C producing 1. If it is a final state, then it should be C producing 1. Other way, it is the initial state as well. So we are considered C producing 1 yes. Similar to that, Q1 on input 0. Q1 is A on input 0. Next state is Q naught, where it is S, as well as Q naught is a final state. So yes on input 0 goes to final state. That's why A producing 0. So two incoming transitions for Q naught as a final state. So two terminating transitions will be there. Rest all can be expanded. Rest all can be expanded. And yes produce epsilon. This is there. So three are the transitions which are directly terminating. There is no further expansion for that particular transition. Are the right linear grammar function rules. In each case, you can see that The non-terminal appears as a rightmost symbol. Terminal appears as a rightmost symbol. And if only terminal is there, then it is 0, 1 or epsilon. And there is no non-terminal. No issues about position. Clear? Is it clear?
Yes, sir.
Next, second one, convert grammar to DFA. Grammar to DFA. Just understand the concept. Later on, you can solve the questions. Now, for yes, let me write Q0. For B, let it be Q1. And for C, let it is Q2. Now, is there any epsilon production from start state? There is no epsilon production from start state. That means start state is not a final state. And here we have two productions, C producing A or B as well as B producing C. So for these transitions, we need to add one final state. Let me write it as a QF. Final state. So these are the states required. How to identify it? For each non-terminal, replace it with some state name. Yes, B and C. Three are replaced, yes, B and C. Then what are the terminating production rules? That means which are producing only terminal. Production rules which are producing only terminal. For them, we have to add final state. But to add final state, first check whether start state produce epsilon. In this case, there is no epsilon production from start state. That means start state is not a final state. We have to apply this conversion rules of DFA to regular expression. Whatever we have seen there, same here we are applying, but in the reverse order. So as there is no production from S to epsilon, S is not a final state. That means another final state is there. There is another state which is a final state. I cannot consider B or C as a final, because for B as an input on B, it goes to C. On C, it goes to final state on input A. On input A. So let me write it here. Q0 is the initial state. From yes, there is only one production. B is the input and it goes to state Q1. Why it is Q1? Because we have replaced capital B with Q1. So on input B, shift this B to transition. Capital B is a Q1. Then from Q1, that is capital B, there is a production BC. On input B, it goes to some state C. What is C? Q2. Q2 is the next state. Same way from B, there is a transition on input A. So for input A, there is a transition to state B. That means it is a self loop on input A. Starting point and end point both are same. That is a self loop. On input small c, it goes to final state because there is no non-terminal. Non-terminal is absent. That means it goes to some final state. Let me write here as a QF and input is small c. Then from capital C, that means state Q2, there is a transition. Now for these two transitions, there is no non-terminal on the right hand side. That means for any input A or B, it goes to final state. From state Q2 on input A or on input B, it goes to final state. I have a double circle. For this double circle, what it is? Final state. And this is the DFA. This is DFA. Clear? This is required DFA. Now, second point, left linear. We have seen right linear. Now left linear and DFA. Interconversion. Left linear and DFA. Now there is a slight change in the rule. In both the cases, left linear to DFA and DFA to left linear. So first DFA to left linear. DFA to left linear regular grammar. This rule, interchange start and end state. Start and end state. Second, first start and end means it is final state. It is a final state. Interchange them. Then reverse directions. Reverse direction of all transitions. For each transition, reverse the direction. We are not interchanging remaining states. We are just interchanging start and final state. Q0 and QF. Then reverse the direction. And third, write grammar from all these transitions in left linear format. Now write production rules. In left linear form. These are the three rules for conversion of DFA to left linear and left linear to DFA. Reverse to this one, whatever we have done in the DFA to left linear. First draw the transition graph. Draw transition diagram. From given transition, as it is, you have to use it. For given production rules, draw the transition diagram. So it will give you the transitions. Then reverse direction of all transitions. Then third, what will be the third point? Even interchange
Interchange start and end.
start and final state. So whatever we have done in the DFA to RELL, we have to perform reverse of that. Interchange start and final state. This is the last step. First draw transition diagram, the reverse direction, then interchange start and final state. Then carry out this conversion from the left linear to DFA using three steps. Using these steps. These are the rules in left linear to DFA and DFA to left linear. Example, given DFA, write left linear grammar. Q naught is the initial state. Then Q1, Q2, so this is the final state, and let's have one more state, Q3. Then Q0 to Q1 there is a transition on input A. Q1 to Q2 there is a transition. Q1 to on input A. From Q2 on in uh, A goes to Q3. From Q3 on input B, it goes back to Q2 and B on A. And Q2 B, so it goes back to Q0 B. For string start, it should be input A. If you start with A, then only it goes to next one. Else it remains on the Q0 itself. So string should start with, string should accept A, change the state. It should not start with A, but it can start with A. If number of B's are there at the start, it will not change the state. It will remain on the initial state itself. So it should accept A, then followed by any number of A, and then B to go to the final state. Now find out left linear grammar. Left linear grammar. This is DFA to left linear. First method. Interchange start and final state, reverse directions, and write production rule in left linear format. So first interchange the final and initial. So Q0 and Q2. Interchange them. Reverse all the directions. After reversing all the directions, then write down the production rule. Rename them. Q0 is yes, Q1 is A, Q2 is B, Q3 is C. Then write down all the production rules. Instead of writing non-terminal on the right hand side, you have to write it as a leftmost character in the production rule, and then it is followed by terminal. How it is? For example, Q0 is yes, Q1 is A, Q2 is B, Q3 is capital C. Interchange initial and final and reverse the direction. So it is, let me write directly, B, A, S, and C. So B is a final state. Here B is a final state, so keep it final. After interchanging wherever it is, it should be marked as a final state. Do not mark yes as a final state. Yes is a start state. Then reverse the direction. Where it is A to B, A, A to B on B, B to yes on input B, A to A, it will remain as it is A. Then it was Q1 to Q2, so now it is yes to A on input B, yes to C on input B, C to yes on input A, and A to C on input A. A Okay, all the transitions are shown. Now write down production rule. So let me start with yes. Yes will remain start state. Yes on input B capital C. Next state is capital C and input is B. It is left linear, so leftmost should be non-terminal. Second is yes producing from yes to A. Capital A on input B. Then A to A on input A, or A to D B to D on input A. It is B. A to B on A, or it is A because B is a final state. A to B. I can expand this B, so I have written B. Or if I want to terminate there, so it is only A. A to A to B, right? Then A to C, this one, capital C, A. Then C, outgoing transition to state A on input A. C to yes on input A. Then for B, it is B to B on input B, or it will just produce B. And B to yes on input B. So 1, 2, 3, 7, 8. We have 8 production rules plus 2 for this final state. Total 10. 1, 2, 3, 4, 5, 6, 7, 8. These are for non-final state. And if we consider B as a final state here in this case, so 2 additional A and B. Total 10 production rules. This way you can cross verify. Just giving the simplification. Simply a simple way to just cross check whether it is satisfying the condition or not. Okay, this is it, the conversion of left linear to DFA. For DFA to left linear, you can just go through the book, or I will share the question on call poll. Try to solve them. One more point is remaining, that is left linear to right linear to left linear. Conversion, interchange, or exchange of these two. Right linear grammar, draw the transition graph, and from transition graph convert to left linear. So while applying this conversion, apply the rules. Right linear to transition graph, directly conversion is there. While converting transition graph to left linear, we have to apply this interchange, change the direction, and then write the rule. That way it will become right linear to left linear. Same way you can convert left linear to right linear. Again, left linear to right transition diagram, the conversion rule, and transition graph to right linear conversion. Okay, that's it for today. And for third unit, one case study is there that you have to learn by yourself. How to use grammar for parser for XML parsing, and in XML language how it is used, that you have to understand. That is case study, so do it by yourself. I'm sharing attendance link. Just mark your attendance and then you can leave. Link is shared in chat box. Just mark your attendance and then you can leave.